All right, here's the 4.3 homework. It looks like an especially long homework assignment. 20 points, 18 different problems. One of them is worth 3 points, as you'll see as we go through these. And that's true in terms of the number of questions that you see, but I think in terms of the amount of time you spend on this, it won't be that bad. I think a lot of these will go really quick for you. The reason I put so many on is because logs tend to be something that students need a lot of repetition with. So I really wanted to get you that repetition because this is what we're going to be doing for the rest of this chapter. And I know from experience that if you don't get a solid foundation with it early, it makes the rest of the chapter kind of miserable. So hopefully this isn't a painful homework assignment and instead good use of your time to go through and practice all these problems. There's basically two types of problems. The first type, it's the first 7 or so of them, just ask you to change either logarithmic form into exponential form or exponential form into logarithmic form. So it should follow pretty closely to the first video that I made in this section. The log base 2 of 16 equals 4 can be rewritten as something to some power equals some number. And maybe based on these numbers, you can just figure this out. But it'd be nice if you could not only figure it out when the numbers are a little bit easier like this, but also when the numbers are a little bit harder like you see here. Something to some power equals some number, where those three somethings are an 8, a 1 divided by 4096, and a negative 4. Similarly, in question 3, we start out with this logarithmic equation. Note that there's no base here. Maybe from the third of the log videos that I made, you understand that there's an implied base when something's not listed. And once you know that base, maybe you can rewrite this equation as an exponential equation. Similarly on this one, except now we're mixing some letters in and some numbers, but that's okay. As long as you're comfortable switching from log form to exponential form, these first 4 should be pretty easy. And the next few, it's the same idea, just going in the other direction. Now they're starting you out with an exponential equation, and what you want to do is switch that into a logarithmic equation. So the log some base of some number equals something, where all those somethings are 5s, 4s, and 625. As far as writing out logs, I believe they have that as a function in here. If you go into functions, you can see log, and then it'll let you fill out the base, and then on the normal line, write the thing that you're taking the log of. Question 6 is a lot like question 5. They start you out with an exponential equation down here. It's just now you got some letters and some numbers floating around, but don't let that mess with you. Question 7 is the last of these types where they start you out with an exponential equation. They actually give you 2. You're going to do 2 different problems in question 7, and you have to rewrite each of these in terms of a logarithmic equation. And note that since your base is e here, you don't want to write log base e. There's a shorthand notation that you can use to write that. Hopefully you're comfortable with that. That came from the third of the log videos. And then for the majority of the remaining questions, all you're doing is evaluating some log. So the log base 4 of 1/16, what's that equal to? You could solve this 2 different ways. One way would be to set it equal to x, and then to rewrite that logarithmic equation as an exponential equation. But ideally, you'd be able to look at this and just tell what the answer is. You'd understand logs to the point where you understand what question this is asking. And once you know what question is being asked, maybe you could figure out the answer to that question and write it over here. Similarly on this guy, what's the log base 5 of 1/25? What's the log base 2 of 2 to the 1/3 power? What's the log base 9 of the square root of 9? So just a bunch of different logarithm questions that you're supposed to evaluate. Sometimes we got radicals, sometimes we got fractions, sometimes we got exponents. And if you're good with your different exponent rules, maybe you could solve all of those guys. Another one, more the same, the log base 3 of 27. Question 13 is slightly different in that they don't list a base for you, but maybe you understand when it doesn't list the base what the implied base is, in which case you can figure out this log, the log of 1 over 1,000. Question 14 is kind of a weird case, the log base 6 of 1. You might not see the log base 6 of 1, but you'll see the log some base of 1. The idea of question 14 is that it doesn't matter what the base is, the log with any base of 1 will be equal to something. Maybe you could figure out what that something is. Question 15, we got the log base 8 of 8. So 14 and 15 were meant to kind of make generalizations. The log any base of 1 will be equal to something. And then anytime the base and the thing you're taking the log of are the same, that'll give you some answer. 16, the natural log makes you understand what base the natural log is referring to of e to the negative 3rd power. Maybe you can deal with that. And then the last question that's not extra credit, this is the one that's worth 3 points because you have to do so much work on here, are a whole bunch of natural log questions. But I think once you get the hang of them, you'll be able to do these pretty quickly. So understand what base your log is when you see natural log. And once you know that base, I think you'll be able to evaluate all of these using our different exponent rules. For extra credit, you see question 18. It's kind of like question 17, but in my estimation, it's a little bit harder. There's lots of different parts here. You can do them if you want, you don't have to. Some of the parts like E here and B and C are pretty similar to what you see in question 17. But A and D, for example, are a little bit harder. But I think you can talk yourself through A. If you understand that the natural log of something, so I'm just dealing with the exponent here, is really the log base e of that something, then the exponent up here is asking you the question, what power do you have to raise e up to make it equal to the square root of 6? And you're like, I don't know what power I have to raise e up to make it equal to the square root of 6. But that's okay, even if you don't know what that power is. If you understand that the natural log of the square root of 6 is the power that you have to raise e up to make it equal to the square root of 6, and then you realize that you're taking e and you're raising it to that power. Let me say that one more time. We are raising e up to some power. And that power is the power that you have to raise e up to make it equal to the square root of 6. So if you take e and you raise it up to the power that you need to raise e up to make it equal to the square root of 6, I know that's really complicated, but maybe you can figure out what that's equal to. Later in the class, we'll be able to generalize this result, but for now, you're just supposed to think about, based on the definitions, what would this be equal to? I think you could do that for both A and for D, and I think in both cases, it's kind of hard, but once you see it, you're like, oh, that's really obvious. At any rate, it's extra credit, so if you don't get it right now, don't worry about it at all. And that's that homework assignment.